Hello, I'm Chichi.
I'm Lala. I'm Lele. I'm Riri. I'm Yanyan. I'm Pepe.
Hey there, Dada here.
Welcome to MathARCTICA, where we solve problems in a breeze of time. Our lesson for today is problems involving related rates. But Dada, what are related rates?
In differential calculus, related rates problems involve finding a rate at which a quantity changes by relating that quantity to the other quantities whose rates of change are known. The rate of change is usually with respect to time.
Huh? Nani?
Because science and engineering often relate quantities to each other, the methods of related rates have broad application in these fields.
Differentiation with respect to time or one of the other variables requires application of the chain rule, since most problems involve several variables. So how to solve problems involving related rates?
It's easy as 7 steps, you know.
Huh? Nani?
First, draw the diagram if applicable. Number 2, write the given data including the known rate of change. Identify what rate of change is decreasing. Make the quantity negative.
Number 3, use your knowledge of geometry or trigonometry to be able to write one variable in terms of the other variable.
Fourth step is to write an equation that relates the variables concerned. Then number 5, differentiate both sides of the equation with respect to time. The chain rule and implicit differentiation are needed in this step. Do not substitute values for variables that are changing before taking the derivative. Number 6. Substitute the known rate of change and the known quantity in the equation.
Then lastly, number 7, solve for the required rate of change. It's easy as 7 steps, you know. Uh-oh, we have problems.
3 of them to be exact.
Come on, let's solve them right away. Would you come with us?
We're going to help you no matter what.
Alright, here we go.
Problem number 1. A spotlight is on the ground 20 feet away from a wall, and a 6 feet tall person is walking towards the wall at a rate of 2.5 feet per second. How fast is the height of the shadow changing when the person is 8 feet from the wall? Is the shadow increasing or decreasing in height of this time?
In this case, we want to determine the y derivative when the person is 8 feet from wall, or x is equals to 12 feet. Also, if the person is moving towards the wall at 2.5 feet per second, then the person must be moving away from the spotlight at 2.5 feet per second. And so we also know that x derivative is equals to 2.5. In all the previous problems that use similar triangles, we used the similar triangles to eliminate one of the variable from the equation we were working with. In this case, however, we can get the equation that relates x and y directly from the two similar triangles. In this case, the equation we're going to work with is
Y over 6 is equals to 20 over x. So y is equals to 120 over x. Now that all we need to do is differentiate and plug values in to solve to get the y derivative. Y derivative is equals to negative 120 over x squared times x derivative. So y derivative is equals to negative 120 over 12 squared times 2.5. Which will give us the answer of 2.0833. So the height of the shadow is then decreasing at a rate of 2.0833 feet per second. A spherical balloon is being inflated at the rate of 350 cubic centimeter per minute. How fast is the radius of the balloon increasing when the radius is 5 centimeter? Let's start the solution by dV over dt is equals to 350 cubic centimeter per minute. What is dr over dt when the radius is 5 centimeter? Given that the volume is 4 over 3 pi r cubed. Differentiate. dV over dt is equals to 4 over 3 pi multiplied by 3r squared dr over dt. So dV over dt is equals to 4 pi multiplied by r squared dr over dt. So substitute. 350 is equals to 4 pi times 5 squared dr over dt. Then 350 is equals to 100 pi dr over dt. Transpose. So you get dr over dt is equals to 350 over 100 pi. The final answer would be 1.114 centimeter per minute. A plastic container in the shape of a cylinder is being filled with coconut juice at the rate of 455 cubic centimeters per second. If the radius of a plastic container is 20 centimeters, how fast is the height of the coconut juice rising? Let's start the solution at the radius is 20 centimeters. dV over dt is equal to 455 cubic centimeters per second. So what is dh over dt? Given that the volume is pi r squared times height. V is equal to pi times 20 squared times height, so the answer will be 400 pi times height.
So differentiate. dV over dt is equals to 400 pi dh over dt. Then substitute. 450 pi is equals to 400 pi dh over dt. Transpose. So you will get dh over dt is equals to 450 pi over 400 pi. Cancel the pi, so you will get 9 over 8 centimeters per second. Simplify, so you will get 1.125 centimeters per second.
I'm Chichi, the light blue quirky penguin, now signing off. I'm Lele, the pink striped penguin, now signing off.
I'm Riri, the green helpful penguin, now signing off.
I'm Pepe, the red green penguin, now signing off. I'm Lala, the red rebel penguin, now signing off.
I'm Dada, the yellow bright penguin, now signing off.
I'm Yanyan, the royal blue penguin, now signing off.